Dear students, today we are discussing some concept on association of random variables. Okay, sometimes we may have different situations in which the variables are associated at the same time they are independent. Okay, what is meant by association? That means if I will show you by using a graph. So uh, association means if x increases then y is also increasing, we can say that there is some association between that variables. We can see that when the petrol price increases, then we can see that the market price also increasing. Okay, okay, so look at these figures. What is the specialty of this figure? When x increases, automatically y is also increasing, but not necessarily in the straight line. At the same time, we can see a trend of increasing nature. Okay, so this is a good example of association. Here x and y are, we can say that x and y are associated. That means let us consider the x-axis is a life of one variable, one component, and y-axis another life of another component. If the life of one component increases, then if the life of the other component also increases, then we can say that there is an association. Okay, and look at this electric lines. What is the specialty of electric lines? Have you seen that? In your home, you may be using three-phase line. Okay, like three-phase line. Okay, this will be neutral. This will be positive. This will be positive. This will be positive. So in a three-phase line, suppose during a rainy season, if this line is get off, what happens? The load of this line will be increasing. Okay, if one of the line is in failed state, then a load of the remaining lines will be increasing. So at the same time, these are independent. They are supplying the electricity to different houses, and they're working independently. Okay, so this is another situation. And you can see that in what is that? Battery setup in a computer lab. What will be the you can see. And this bed is not seen. Power supply. I'm not getting some proper figures. Anyway, think about our lab. What is the specialty of lab? We have 14 or 16 systems, and each of the system are getting power from two set of or four set of batteries. Okay, we are connecting 16 system using four set of batteries. You know that if at least two of the batteries are working properly, then the system can be what is that? The system can be in operating state. Okay, I think out of N system, some sliding window system. Proper. Okay, think about the situation that at least two number of batteries are working. Think about computer lab. So for this system to be working state, we have to ensure that at least two out of four systems are in are providing sufficient power supply. Okay, so what is the speciality of that computer lab? We should ensure that and suppose if all the batteries are in working, then they can give proper power supply in proper time. Okay, proper power supply. At the same time, if any two of the batteries are failed, then the computers will use the power supplied by remaining two number of batteries. So the load to the working batteries will be increasing. Okay, the load to the working batteries will be increasing. So naturally what happens? Soon after after 1 hour or after 1.5 hour, the third battery will be also in they'll be also going to fail. Okay, so due to the increased load, so this type of load sharing systems we use the concept of association. You know that the components are independent, at the same time they are associated. Okay, sometimes it may be linear association. Okay, linear association, or it may be non-linear association, or whatever it is. Life of one component is increasing, then the life of the remaining component will be also increasing. This type of association is called positive association, and you can see that this is negative association. When X increases, Y decreases. Okay, positive, negative, and so we can see several association features. So what is the use of the concept of association in reliability theory? So that we are discussing in this paper. This is a fundamental paper of association of random variables with application due to SRA, Boston, and so you can see in our book, in that chapter, we can see the results in these papers. Okay, so formally, how can we define the association? You know that in this case we say that this correlation is positive. Okay, this is positive correlation. This is a situation of positive correlation. This one. Okay, that is a situation of positive correlation. So
what we have here is 6 different scatter plots that show the relationship between different.
This is a positive correlation. Okay. So what would be the plausible definition? Instead of correlation, we can use covariance. Okay, without standardizing the variation, we can use covariance. If we standardize the results, we can use correlation. Okay, we need not to standardize for measuring the association. So the how can we measure? The covariance of S comma T is equal to expectation as T minus S minus T. If it is positive, then we can say that there is a positive association. Okay, and it can generalize, or it can we can define more strongly by imposing the covariance operation to f of s and g of t, where f and g are non-decreasing, increasing functions of f and g. So this result is required in our reliability theory. Okay, this is strong. A more strong definition is covariance of f of s comma t comma g of s comma t greater than or equal to 0 for all pair of increasing functions f comma g which are non-decreasing in each argument. Then s and t are still more strongly associated. Okay, so this is a now we consider a couple of random variables. That means T1, T2, a set of random variables T1, T2, Tn are associated. Okay, then we can say that the set of random variables T1, T2, Tn are associated if covariance of f of t vector t comma g of t is greater than or equal to 0 for all non-decreasing functions f and g for which expectation exists. Okay. Now we look at some properties. These properties are useful in computation of reliability bounds. Okay. So what are the properties? First property is any subset of associated random variables are associated. Any subset of associated random variables are associated. Second property is if two sets of associated random variables are independent of one another, then their union is a set of associated random variables. Okay, it's a good property. If two sets of one set is S1 S2 Xn and other set is T1 T2 Tm, then its union, that means S1 S2 Xn comma T1 T2 Tm are it's a set of associated random. We are not referring the proof because we need only the property. Another property is the set consists of a single random variable is associated. Another is non-decreasing functions of associated random variables are associated. You know, the structure function of a coordinate system is non-decreasing. So we can use this property to the structure function. So non-decreasing functions of associated random variables are associated. Another is if T1, T2, Tn raised to k are associated for each k. So we can these are the concept of association we are using in our reliability analysis. This paper gives a more theoretical framework for the association concept of random variables and set of random vectors. And this is another property of association of binary random variables, because we are dealing with binary random variables. So if x1, x2, xn are associated with binary random variables, then 1 minus x1, 1 minus x2, x3, 1 minus xn are associated with binary random variables. That is also we are using in our reliability analysis. You can see, let x1, x2 associated with binary random variables. Then probability of x1 equal to x1, comma, etc. xn equal to xn greater than or equal to probability of x1 equal to x1 into x2, probability of xn equal to x1. Okay. Similarly, probability of x1 equal to 0, etc. xn equal to 0 greater than probability of xn equal to 0. This is a result. We will use these results in our reliability analysis. For binary random variables x and y, association is equivalent to covariance of x comma y greater than 0, as we seen in this figure. This means associated means covariance will be greater than or equal to 0. Okay, so along with my research guide Dr. M. Manoharan, I have conducted this type of association analysis in the stochastic process, and we have published in the Journal of Statistics and Applications. Almost similar results we have obtained for the stochastic process. I will show you that also. Our paper recently accepted by Journal of Statistics and Applications. This is that paper. This is actually my PhD work. Yeah, it is our result on association time of Markov process with application to reliability and survival analysis. This we have discussed the concept of association using of the stochastic process using transition probability matrix. The key tool for analyzing the Markov process is transition probability function, and we have used that transition probability function and proposed weaker condition. So these are our results. You may not be able to understand the concept in detail. At the same time, you can see that you can look at these results only for getting the idea about the association. Okay. So anyway, I think we will now we will go to the these results are we have discussed in this section. Yeah, these are some examples. Minimal path structures of a coordinate system having components in common. They are associated components subject to the same set of stresses like electric line. That is associated structure in which components share the load, so that the failure of the one component result in the increased load on each of the remaining components that result in failure of the remaining components. So that there is a what is that association with the in between the components in which they are if they are sharing the load. Okay. You can see load sharing systems. I will show you. Power generation. Plenty of analysis is available in reliability theory, which are related to the association, bounds on system reliability, etc. So we will study the application of this concept of association in reliability in the next class. Okay. Okay, thank you. I will share this paper with you, and you can write down the results only. You need not to go to the proof, but at the same time you can read and try to understand the concept, and you may write down the properties only. Just property മാത്രം എഴുതുക കേട്ടോ. Okay.